the webinar today. My name is Emily, and I'm from the new Planning Center. I'm kind of overseeing the training and education. We see it as a really, really important way to reach our clients. We feel like nowadays there's a lot of good planning centers. There's a lot of good items on the market, but the biggest differentiator between these different companies out there is their ability to offer training and education to stay connected to their clients. So we are really working on building our training and education library. You'll be able to find the videos, webinars, and so forth when you go to our website. We'll have a little bit more information about that later, but want to thank again everyone for joining. I have kind of got some notes here, so I'm going to refer back to my notes here. With us today, we have Michael Bradley. Michael Bradley is one of the main planners, our implant planners here at the new Planning Center. Michael, thanks for joining today. We're glad to have you. You look extremely serious, so hopefully that this whole presentation isn't this serious, but thanks again for joining today.
Well, thank you. That's my listening face. I get more angry when I listen. So,
Okay, hopefully you get nicer as you present. So we'll keep our
yeah.
fingers crossed. And then our guest today, and I have to say how super grateful we are for this. So we've got Richard Cromwell here. You see him there on your screen. I'm going to put his bio in your chat, in the chat box here in just a minute, so you can go through and read a little bit more about him. While we were kind of waiting to start the webinar just now, I found out that Richard is basically a jazz pianist. I don't even know if I'm jazz or whatever, like coming from an extremely unmusical, untalented person. I also found out he does fencing. So I don't know, Richard, we're kind of fans of yours now. We just want to thank GoEngineer for their willingness to join us on this webinar session. I have to say that we're going to be focusing on Formlabs in clinic printing. And we reached out to Formlabs directly. We wanted to go to the manufacturer basically to see if they would be willing to help us teach our clients a little bit more about how they could be in more control of their implant planning process, the time involved, just kind of putting the patient at the very forefront of the whole process, getting things done quicker. And they referred us to GoEngineer. After doing some research, if you guys ever are interested a little bit more about GoEngineer, their headquarters is based in Salt Lake City. They have a huge following on YouTube. It's really, really fascinating when you go through and you start kind of to sift through some of their videos there. So Richard, thank you so much for your willingness. We know it took preparation. We know it took pre-recording in some cases, but thank you for joining us today. We appreciate it.
I'm happy to be here.
Wonderful. And then kind of in the background here, you guys will see him in a little bit. We've got Drake Quigley, also part of the GoEngineer team. He's going to stick around towards the end of the webinar and help answer some questions. Hopefully you guys have questions. That leads me to my next comment here that we will be having a Q&A session at the very end of the webinar, but as your questions come up throughout the process, you'll see a little chat box on the right-hand side of your screen. If you're joining from your laptop or a phone or something, just click that little chat, or I'm sorry, the question box. You'll see a box with a little question mark in it. Type your questions. They'll come directly to me, and I will read the questions to either Richard, Michael, and then also we have Drake, who will be answering the questions at the very end. Last but not least, I want to let everybody know that we are recording this session. So those of you who attend live will receive the recording in about 48 hours after the webinar. We like to give ourselves a little bit of time to edit any things that might go wrong, or just maybe to cut them down in time a little bit if need be. So watch for that webinar recording link. And then those of you who, well, I was going to say those of you who actually didn't join live, but you're not here, so that's okay. Again, the recording will be up on our website. So that being said, I think that Michael, you've got presenter ability, and you know what? I'm just going to really quickly pull this up here and just give a little bit of background here. So our topic today is how in-clinic 3D printing can optimize guided surgery. And it's basically about how to elevate your implant workflow with in-clinic 3D printing. Okay, so what we're really, really kind of wanting our clients and end users to see is that the time that it takes often to get your guide back from a lab could be a couple weeks, if that. Slowing the process down a little bit for patient treatment. What you're going to hear from Richard once you get we get to his part, you're going to see how quick this process is and how simple it can be for you to do this in clinic. So that being said, I'm going to go ahead. Michael, we're going to start with you if that's okay. If you want to go ahead and share your screen, and then I'm just going to stop sharing my camera until the very end, and we'll come back for the Q&A. But if you want to go ahead and jump into it. And I know, Michael, as a new planning center, what you're going to do is just show us the basics of implant planning, right? What you do on a daily basis. Nothing too tricky. We're starting kind of from square one right now. We'll have future webinars where we'll be actually kind of dive deeper into some more of these technical ideas and what you guys do. So let's go ahead and have you share your screen. We'll let you jump right into it. And then from there, we'll have Richard take over.
Okay, I'm going to share my screen. Let me know if you guys can see it.
Okay. Not yet. Okay, it looks like it's coming up here. Sometimes it takes just a second. Okay, yep, we got it's all yours.
You can hear me still?
Yep.
Okay, so you can see this. It's a little bit flashy on my side. I pre-recorded a video as well if my software is not going to let me run GoToWebinar and the software at the same time. So just let me know if this is shaky or if it's pretty smooth. Does it look smooth on your side, Emily?
Well, so far it looks good. As far as I can tell, you haven't moved it a whole lot. If you are moving, okay, yeah, no, I think it's pretty good. And just as kind of a disclaimer here, when you run the GoToWebinar service, it takes up a lot of bandwidth on your computer. So every now and again, when you pull up different softwares, it can appear glitchy, even if it's not glitchy. So we'll let you dive into it, Michael, and I'll let you know if there's any issues on our side as we're watching.
Okay, and like I said, I have it recorded, so if we need to, we can switch. But so let me just jump in here. This is going to be really simple. We're just going to give a quick run through kind of just basic implant planning, guided surgery, and just how the process works. So if you can see my screen here, you can probably see this bone volume. So it's a CBCT scan generated by a 3D model. So this is a beautiful scan. You can see all the cusps of the teeth very well. There's not a lot of scatter. It's out of occlusion, which is really important because we need to find those the cusps of the teeth in order to align the models with the bone volume. So this looks really good. Just kind of as a reference, I wanted to show you maybe not so great CBCT. You can see this one, a lot of scatter here. It's hard to see the cusps, so it's really quite difficult to align it with the intraoral scan that you get from scanning the teeth. And also, if you look at the front of the jaw here, you can see this ridge, and you can see a double layer of teeth. So this person obviously moved when the scan was taken, and we're not going to be able to get a very accurate implant placement because we don't actually know where their jaw is in correlation with the other side. So it's important that you get a nice CBCT scan, and we can talk about that. This is just a quick run through. I'm not really trying to sell you on how to do a good CBCT. Good STL file right here. This is where we're placing the implant, tooth number 13. Look at all that gingiva that's scanned. We're going to talk about why that's important in a couple minutes. And we have a full arch. We always want a full arch, all of the teeth, because we want to make a surgical guide that goes from molar to molar if possible. So let me show you just for instance in comparison. Here's not so good of an STL file. So we have some artifacts here. Maybe it's the person's lip or cheek. We have some holes in the model right here, which is going to be very difficult to create a base because the software is going to freak out with holes in there and things like that. So this is something that we don't want to see. Anything that's on the STL file or the intraoral scan, that's going to be on the surgical guide because that's the surgical guide just recognizes that as what the teeth are. So if you have all these weird artifacts and bumps and if if there's a lot of saliva in the patient's mouth and you didn't dry it properly, that's going to be part of the surgical guide. So you need to make sure that you have good scans when you send them to us. Here's another one that I want to show. This is a partial scan. So often doctors will just want to do a partial guide, maybe like from the canine to the molar. And we don't like to do that because it can shift during surgery. And that's something that we'll talk about later as well. You can see all these artifacts again. So anyways, this isn't really the topic of what we're doing today, but I just wanted to show you a couple examples of what we're looking for and what we're not looking for. So this looks great. Once we get the bone volume, then we can align the intraoral scans. That's the upper. There's the lower. You can see how they pretty much perfectly match. Looks really great. Let's remove these things. So again, we're placing an implant here in the upper left. So I'm going to pop that implant in there. So here's the implant in place. Now you can see my screen. This is a BioHorizons implant, this yellow thing here. and it's a 4.2 by 12. So what we do is we have, we get the files, we plan the surgery, and then we send a Zoom invitation to the doctor. And the Zoom invitation goes out, the doctor schedules the meeting when they want to, and we jump on a Zoom call. I share my screen, or one of the other planners shares their screen, and this is basically what we show them. We say, okay, buccolingually, you have a lot of space. We have bone coverage all the way around. You can see the roots here. If you look at that, that margin around the implant, if you look at the bottom right of the screen here, that's the safety margin of 1.5 millimeters. So we try to stay 1.5 to 2 millimeters away from any adjacent roots. So you can see there we're well within that distance to that molar and to the bicuspid. And once we get approval from the doctor might say, you know, I want to make it longer so we can stretch it out, or I want to make it wider. So whatever the doctor says, that's what we go with. And once we get approval, then we begin the process of creating a surgical guide. So that's what I'm going to do now. Let me know if my software glitches here as I select some things. Okay, I want to get the upper model. And okay, so here's my upper model. This is my sleeve right here. That's going to be what you're going to be doing surgery through. So I'm going to select my camera direction to create this guide. That looks pretty good. So that's basically the direction that the guide is going to be inserted into the mouth with. And I'm going to move to the next step, into the next, and I'm going to select guided area. So this is kind of tedious to watch, but I'll kind of talk with you as we go. So this is one of the reasons why we need good STL files, as we said before, or intraoral scans, is because we're creating this guide to go right on that intraoral scan file. So if the scan is bad, then the guide is going to be bad. Now this again, it's a beautiful file. You can see all this rugae here. Everything looks great. There's not a lot of saliva. There's no scans of the lips or anything like that. So we're able to get a very accurate guide here as we go along. And often when we have a file, like an STL file, the file is great, but they just didn't scan enough tissue around the teeth. So they get the teeth, and you know, the guide stops about right at the gingiva, or even before they get to the gingiva. They're just basically scanning, you know, the tooth and the occlusal surface. But we really need this gingiva surface so that we can build and create a guide that fits the entire tooth. All right, so as I'm going along, I'm clicking. And another reason why you want to get the gingiva in your STL file is so that if we need to do something like place pins, or if we need to pull the guide out a little bit more if there's missing teeth so that we can have more surface area to create a stable guide, then we have the freedom to do those things. And maybe we can talk about that more in detail later on. But it just really gives us a lot more freedom and a much better guide if you can scan, you know, at least 2 to 5 millimeters of gingiva above that tooth, or above all of the teeth, so that we just have a lot to work with here. Okay, so I've created that outline of where I want the guide to be. I hope that the software is doing okay. It's bouncing around a little bit for me, so hopefully it's smooth on your guys' side. Okay, I think it's going to be okay. All right, so now we have the guide here. That's what's going to be printed in the 3D printer. Now, just to make it more user-friendly and to make sure that the doctor is aware of what's going on, we're just going to make some windows here. Okay, so I'm going to give a window here in the molars. So this is something that the doctor, that's very helpful for the doctor, so they can see that the guide is seating properly. If you don't have these windows, the guide is going to be, you know, slightly translucent as far as the material that it's made out of, but it also helps to have these windows just to see that the guide is fully seated to the teeth. I'm going to make a little cut here, and let's do one in the front as well. Okay, sorry, this probably isn't the most exciting to watch, but maybe you've always wondered how a surgical guide is made, and now all of your anticipation is paying off right now. So we want to make sure these windows don't cut in too much to the guide, because we still want enough material to have a strong guide. So if we're cutting it way down, you know, if there's only a few millimeters of space between one edge and the other, then we might have a broken guide. So we want to make sure that it's nice and strong. I'm also going to add a label here. Let's call this demo. Very creative. Let's make it a little bit bigger. And we'll place it right in front here. Okay. So here's the surgical guide. We got the patient's name on it. We got the windows into it, and we are done. Pretty simple, not too crazy. Now, with this process, you can see it's pretty quick the way that it goes. And then what usually happens if you don't have a printer in clinic, then we're going to ship this off to the lab, maybe with the model as well. We usually ship the model also, and then the lab prints the guide, prints the model, and then they ship it to you. So there's a lot of costs. Usually, lab will charge about $65 to $99 for a surgical guide to be printed and to be shipped to you, and then maybe like $25, $30 for a model. So I have a feeling that the gentlemen at GoEngineer and Formlabs can tell you that you could save a lot of money if you printed in clinic with that as well. One other thing I wanted to show you also was, I just want to make sure this is in guided positioning. So we also send you as well, and this isn't entirely part of, I'm just going to call this test doctor. Let me know if you can't see the screen that's about to pop up here, but we also send you a surgical report. So not only do we send you guided surgery, it's pretty foolproof. You just follow the steps in the surgical report. Emily, can you see this report that just came up?
Yep, I've got it. And so really
Okay.
quickly, what I wanted to reiterate was when you said you ship this to the lab, you're just sending the digital files to the lab, and from there they
Correct. Yeah.
manufacture. Okay. Perfect.
Yeah.
Yep,
Sorry
we
to.
see the guide. Okay.
Yeah, so we can send the files immediately, via the internet to the lab, but then they have to physically print it out on their 3D printer, and then they get it back to you. So you can see the drill sequence here. All you do is just follow the steps of the drill sequence, and there your surgery is done. So I just wanted to show you that real quick. But yeah, so you can think about how easy this process is. But like Emily said, we send it to the lab in a file form. They print it out. Printing or the whole lab sequence probably takes maybe 2 to 3 days turnaround time. And then you think about where your clinic is opposed to where your lab is. Your lab could be in New York, you could be, in Ohio, or you could be in California. So that shipping time could be 2 to 3 days, somewhere around there. Let's say it's winter time. There's a big winter storm, and they're slow. All right. Let's say you have a patient that's scheduled for Thursday morning. The guide was supposed to come on Wednesday afternoon, but because of the weather, it didn't show up, and now you have a patient in the chair, and your guide is nowhere to be found. So that's something to think about. Or you could think of other situations where maybe you have a patient on Monday morning and the guide arrives Friday night, and somebody picks it up, puts it somewhere you don't know, or they didn't deliver it because nobody was there to receive it. It was after hours. So there's a lot of unknowns if you're dealing with it being made somewhere else, that you can negate all those things by having a printer in clinic, and it's going to save you a lot of money. Another thing that will cost you money is the sleeve here. So with the lab doing the printing, they're probably going to bounce that price up on the sleeve to maybe 20% higher than what you would pay if you were to buy it from the company. And along with that, these sleeves are reusable. So you could, in theory, you could remove this sleeve and just place it in the next guide that you print out, and you could just have one sleeve that you continue to sterilize and place in the next surgical guide for the next patient. So all those things being said, I'm sure the guys from Formlabs and GoEngineer can tell you more about what you can save and the benefits of having a printer, but it really makes sense in my mind to, we do the planning and then everything goes to you, and you have the power to do all the things that you want, and you have a printer that would be used in the lab anyway. So your quality, you're not losing anything on quality, because the lab's probably going to be using a printer, either the same printer as, like something like the Formlabs 4B, which is their new printer, and I'm sure we'll hear more about it. So your quality is going to be just as great as if you went to the lab as well. So that was all I was going to show today. I don't know if you have any questions, Emily, for what I just demonstrated.
No, I mean, I think that was really informative. It's nice to see how it's actually done, how the process actually comes together. Even the windows, I understanding why they're there, so the doctor can have visibility on if that that guide's seated all the way for accuracy and so forth. Also, the drill reports are super important. And I just want to mention that those drill reports are going to vary, and correct me if I'm wrong, Michael, based on implants, the implant manufacturer, basically everything that plays into the situation based on what the doctor chooses once you place the implants. Those drill reports are going to vary greatly, right? They're very specific to that specific patient and that specific surgery.
Right. They'll vary with, if you're using BioHorizons, for instance, or a MegaGen implant. And they also vary with our software. We can determine the density of the bone. So it'll also give you a drill sequence, so let's say it's pretty soft bone, D3, D4 bone. Your drill sequence will be different than if it's really hard bone, like a D1 or D2 bone. So it
Excellent.
really
Okay.
helps you have a greater understanding of, like you said, specifically tailoring it to the patient rather than just kind of winging it and feeling the, which is also good if you know how to do that and you can really know what type of bone you're working with. But this just helps you have a better understanding of what you're working with and how to tailor the surgery to the patient.
Kind of eliminating the variables that could be potentially an issue. So, okay, great. What I'm going to do now, thank you. We did have a couple questions come through, but I'm going to hold off until after Richard's presentation and we'll just get all the questions going together. Richard, I'm going to go ahead and make you presenter at this point in time, and you should be good to share your screen, and yeah, we'll go from there. Let's see, did you get an invite to share your screen, just to be safe?
Yep.
There we go.
Can you see it?
Awesome. Yep, we got it. Thank you.
All right. All right. Thanks, everybody. All right. Today, thanks everybody for your time. I appreciate everybody jumping on here. And today I'm going to show you how easy it is to print the guides that we just saw being designed as well the models. We're going to show you, as mentioned before, using the Formlabs 4B system, how you can print a surgical guide for about $3.39 for this particular example, the model for $2.61. So a grand total of $6, which is a significant amount of savings over what was just discussed. The reason that GoEngineer recommends Formlabs printers specifically to many of our customers across a broad spectrum of industries beyond dentistry is due to Formlabs' commitment to providing a simple, well-designed and executed end-to-end 3D printing ecosystem. So it's from printers and post-processing equipment to the software and the materials. Formlabs provides an enterprise-level turnkey solution for dental labs, as well as clinicians. Primarily today, we're going to be discussing the Form 4B, which I have behind me, and I have several more Formlabs printers in the other room. This is an MSLA printer, which is a mask SLA printer, a stereolithography printer. It uses a projector and is very fast relative to some of the former Formlabs printers like the Form 4B, which essentially used a laser to trace the vectors and rasters of the part. So kind of like traditional 3D printing, FDM, where you're using a glue gun on a gantry to go around the perimeter and then fill in the center. With a Form 4B, what we're doing is essentially blasting the entire layer all at one time. So it's very, very quick. In the interest of time, I'm not going to focus on the process. Well, in the interest of time, I'm going to focus on the process and workflow of printing the surgical guides rather than the technology inside the printer itself. But I will simply say that the Form 4B and its bigger brother, which is the Form 4BL, are the result of more than a decade of optimization and over the course of 3 generations of preceding Formlabs 3D printing systems. And so these systems are really designed from the ground up for professional use at this point, and they incorporate many features to ensure repeatability and reliability across builds. As a testament to that fact, I like to point out that over 15 million parts have been used in dental applications printed directly off of Formlabs 3D printers. And I also want to mention that all of those parts were largely printed using Formlabs' own portfolio of really high quality in-house manufactured dental resins. These are produced in their own US-based ISO 13485 facility. And the Form 4B is a really versatile printer capable of printing parts for several different indications. And today we're going to be focusing on its use in the production of these surgical guides. And we're going to be using the Formlabs surgical guide resin with a single 1 liter cartridge of resin, which costs about $249. You can easily print over 70 surgical guides before having to replace it. And so one of the things I love about Formlabs, relative to a lot of the other printers that I have access to here, is that the cartridge style resin system minimizes an operator's exposure to uncured photopolymer, and that it really helps to keep things clean. Traditionally, in the 3D printing world, we call resin style printing wet 3D printing because it can get a little bit messy. But with the Formlabs, it does a really good job of keeping everything contained and minimizing exposure to operators. And so when printing a surgical guide using the new system, we first need to calculate the offset or tolerance value that relates to how much space we want between the surgical guide's collar and sleeve so that things will fit together the way that we want them to. And we do this by first printing a series of test parts that a new provides. And we need to orient the parts with the interfacing surfaces facing upward in the z-axis and just run the parts using the default support settings in our surgical guide resin. And after we print and wash and cure the test sleeves, and don't worry, I'll go more into detail about that process in the context of the guides themselves momentarily, but we see which of the test sleeves are going to fit the bushings best after they're printed. And so once we determine our desired offset, we only need to do that one time, and we can just use that value in the future when ordering our guides. The Formlabs 4B and the 4BL printers both achieve high scores in terms of repeatability and consistency across builds. Once we have our surgical guide file, Formlabs preform build preparation and slicing software's dental platform allows us to easily get our surgical guide ready to print. We simply select what type of part we would like to print with the menu of customizable presets, and then selecting one of the presets does a couple of things. It automatically sets the printer up with the correct resins and resolution for the type of indication we will be printing for. And it will also set up the software to automatically orient, support, and lay out the parts using best practices associated with that type of geometry and using the specified material. In this case, we're selecting the surgical guide preset, and we've dropped our part file into the import box, and the software automatically imports and orients and supports the surgical guide. But if we want to, we can easily manually edit the support structures or the orientation as we need it. You'll also notice, like down in the lower left-hand corner, there is a summary window, which displays important information about the build, like total print time, material usage, and the build cost. It looks like printing this guide will take approximately 43 minutes. So now we can just send the job to the printer. So if the printer was already cycled and ready to print, once it receives the job, it would just start printing. But in this case, I want to show you what we need to do between builds and starting a new print. So the first thing we do is load our vat of surgical guide resin there. And then now we're changing the materials really fast. Now we'll remove the cover and secure the vat and plug in the wiper. We install the print head. Oops. Let me go back real quick. We install the print head, and that's it. So like a lot of the time, there's calibration involved with these printers, not with the Formlabs. It's automatically calibrated, self-calibrating. It does it itself. We just close the printer down, and pretty much this is cool. We can install our surgical guide resin. It comes in these like shampoo bottle canisters. So you just drop it in there, open the top. And other than that, we're pretty much ready to go. You can see it has a mixer that will automatically scan across the tray to agitate the resin. It has a built-in resin heater, so that way we can control the viscosity of the resin. The printer does have an internal camera as well, and so you can actually, as well as a host of other sensors to monitor the build in progress. And so you can see the surgical guide printing there. And 43 minutes later, we have a beautifully printed instance of our surgical guide design. However, at this point, it's still covered in photopolymer resin. So it's like dripping with photopolymer resin, and it's still in a green uncured state. So that means that the material properties in terms of like mechanical strength and things, they're not really all the way to their maximum yet. And this makes removing the support structures a little bit easier. So sometimes people will remove the support structures before they go through the wash and the UV post care. In this particular instance, I wanted to show you how easy it is. So you can actually just unload your build head directly from the printer, just pop it out, and then we put it into the form wash unit, which will automatically lower the print head into a bath of agitated 99% isopropyl alcohol. About 5 minutes later, it will raise the print head out of the bath and close the lid, which is cool because it doesn't allow the IPA in the canister to evaporate. And then we wait about 15 minutes, I'd say. The parts you'll see here can be easily removed from the build head just by flexing these tabs, and they'll pop right off. And then we take our clean part after it's dried and we place it into the form cure unit to UV cure the parts and finalize the material properties. The form cure is pre-programmed with the temperature and time recipes for a range of materials. And so we just select the surgical guide resin and begin the curing process. And after quickly heating up to the proper temperature, the form cure begins the timer and irradiates the part from all sides with the UV light. And so then 5 minutes later, we will have our 3D printed surgical guide. And now we just need to finish it up and get it ready for sterilization and then the patient. So I use flush cutters to carefully cut the supports at the touch points and where they're attached to the surgical guide. And it's recommended to wear safety glasses when you do this because like little parts fly all over the place. You could technically just rip the support structures off, but I don't recommend you do that because it will leave like divots potentially in the part. And so we just want to be real kind of careful to individually cut as many of the supports as we can that are connected to critical anatomical features. And then that's it. From there, we can then polish the surgical guide using typical dental polishing methods such as high grit abrasives, and we can smooth out the support marks for patient comfort. For higher levels of part translucency, if that's something you're going for, you can even further polish the guides with pumice and a rag wheel or other specialized appliances. And so here we see the finished printed part. Now, for proper insertion and fixation of the sleeves to the guide, we want to paint the resin, the surgical guide resin, inside of the guide sleeve hole with a micro brush. And then we place the sleeve or cylinder and we push it down into the channel so that the uncured resin coats its outer diameter. Then I used a dry brush to kind of like brush away any of the excess squeeze out. And then we use a UV pen or dental curing light around the margins to quickly lock in the sleeve position. And so in the end, after roughly 2 minutes of file preparation, 2 hours and 10 minutes of collective print time for both the model and the guide. Printing the model is very similar process. 10 minutes of automated washing, 30 minutes of dry time, 10 minutes of cure time, and about 5 minutes of secondary post-processing and sleeve installation. You're going to have your part. So another way of looking at that is after 20 minutes of mostly unskilled labor and 3 hours spent doing other valuable work for your practice, you can have a $6 3D printed surgical guide and model at the end. And it's also important to keep in mind, you can easily print up to 6 surgical guides at the same time or add an additional printer so that one is dedicated to printing surgical guide resin, the other one's, you can dedicate to printing model resin. And then you can print both parts in parallel, which will drastically reduce the time, basically cut it in half. And so with the Formlabs Form 4 printers, the throughput is flexible and scalable. So you have your completed surgical guide and model in the end. And that's pretty much all I got. And I guess we can kind of open it up for Q&A at this point.
Excellent. Okay, I'm going to go ahead. I'll flip my camera back on now, not that anyone wants to see me. You guys are the quality content here. But we're going to get through some questions. And really quickly, before you stop sharing this screen, Richard, you've got your barcode there. People can scan to go directly to your site. And I wanted to mention this. I know maybe Drake's here to talk about some promos and this and that, whatever you guys are doing. I hear all the time about people who potentially have a printer. It's the same thing with an intraoral scanner. That's my background, as I've done a lot of training in the intraoral scanning. there is often help needed in getting started. And I think it's really important that we direct people to the right points of contact, people and quality, quality items, quality printers, but also knowing that your team would actually help with the training, getting people up and running and all that. So I think it's really important that people understand they don't have to be alone when they go through the process. Getting set up initially might be a little bit daunting, but you guys are there to help them. And so I would just suggest everybody goes to your website and this and that. That being said, I'll go ahead and share my camera again. Michael, if you want to come back, Drake, if you want to come back, or come back, not come back, but show up whenever you're ready. Thanks, Drake. It's nice to see your face. Glad you're here. And then maybe Richard, I'll have you pull up that slide right before we end again. So anyone who didn't get a chance to scan it, we're good for now, but then you can just pull it up at the very end. We did have several questions come through. I'm gonna just try to answer them in order of the questions. And then Drake, I'd like to give you a second to chat as well. Is it before or after the Q&A session? What works best for you?
Yeah, we can do that after. Let's get the questions. I like those.
Okay, perfect. Let's jump right into the questions. Okay. So I'll try to get them in order. Hopefully I get everybody's questions answered. Quite a few funneled in. So let's go. We've got the first one from, let's see here. It looks like this one is geared towards Michael. From when I have submitted the files, which are the CBCTs and the STL files, how soon after the planning occurs can I have the files for printing in clinic? So that's a pretty good question for those of our doctors who have actually been working with for a while, and we've been planning and sending it to a laboratory. How much time can you cut out, Michael? I guess is what it comes down to once you do once you work your magic.
So in theory, it really could be the same day. So let's say you have a patient come in the morning time, you give them a CBCT, you scan their teeth, you send us the files. We can plan it, depending on our workload, we can definitely plan it that day, but in most cases, we can probably plan it within an hour or two of you sending it. And then we will send you a Zoom invitation to jump on a Zoom meeting that's about, 1 to 5 minutes long if it's just for one implant planning case. And then once you approve that implant placement, then we send the files to your clinic and you could print it. So in all reality, you could have a patient come in at 9 o'clock in the morning. We have it planned by 11 or 12 in the afternoon, and then you could jump on a Zoom meeting at lunch, and then we could send you the files and you could have it printed that afternoon. With most people going on with how busy dentists are, that doesn't usually happen, but often we have cases where they send us a case and we plan it that day and then they print it out the next morning.
So really, you're alleviating, if I'm saying that correctly, a week, 2, maybe 3, depending on turnaround times, doctor scheduling the patients and so forth. We have patients who are in a hurry all the time. Some of them leaving the country, sometimes there's emergency cases. So you're really, really taking control of the time here. I've got another question. I think this one's going to be for Michael as well. I have placed implants freehand for years. This is a good question. What are the benefits of guided surgery? I think that's probably maybe it's one of the big questions in implantology nowadays. So Michael, I'll let you take that one.
Yeah, and I don't want to, disrespect anybody who's been doing it freehand for years, and I'm sure you're really good at what you do. But guided surgery just enables us to have more security as to where the implant's going. And not only are you, as the doctor, you're placing the implant, but you have a lot more eyes on it. I plan it. Usually there's 2 people on the planning meeting, and then there's a doctor. So you've already had 3 sets of eyes of where that implant's being placed. It's kind of like with guided surgery, it's kind of like riding a bike with the training wheels on, so you're nice and stable. So we recommend, doctors start doing guided surgery, which is kind of opposite of what you see in the field, but start with guided surgery, do that for years, and then maybe you can start to graduate to doing it more freehand, where often we hear of dentists that are afraid to start guided surgery because they've been doing it freehand for so long, but guided surgery is so much safer. And you just remove a lot of the variables in it. So I would recommend, with all of those things, extra eyes on it. Obviously, you're guided in what you're doing. guided surgery. And we work with a lot of oral surgeons who have been surgeons for decades, and everything they do, even if it's just one implant, they're doing fully guided. So it's not like a, it's not a beginner way to do it either. So
I like it. It makes a lot of sense. I don't know from my perspective why you'd dare mess with that otherwise. You just want to get rid of those variables, as you said. Okay, I've got a question here. This is going to be for the GoEngineer team. It's a good question. Why did the guide change color?
That is a good question. So the resin naturally shifts from a translucent yellow to a translucent orange during the post-processing cycle, like during the UV. And then it shifts back actually to the translucent light yellow after you autoclave it.
Wow.
So the color will stabilize once it's autoclaved.
Okay. Okay. From me, coming from somebody who knows very little about printers, I think if I saw the color change initially, I'd feel like I did something wrong. So it's nice to know that
No,
it changes and
totally
then can
normal.
change back. So that's good to
Yeah.
know. Another one for the GoEngineer team, can the Labs resin printers you talked about sorry, the typing's so small here, I'm having difficulty reading this. Can the Labs resin printers you talked about print with materials other than the ones produced by Labs? Okay, man, that was hard for me to get out, but that's a good question. Is it strictly Labs resin, or how does that work?
No, actually, the system is completely unlocked. So it comes unlocked, and you are able to create custom resin profiles for any third-party 405 nanometer resin. Also, for a lot of really popular dental materials from third-party providers, um, like the Keystone key splint materials for bite splints and night guards, all of that stuff, they already have presets built into the machine, so that you
Perfect.
can download. Yeah.
Excellent. Okay, let's see. Michael, I think this one's going to be for you. How do you secure a guide on a patient with minimal teeth or fully edentulous? It's a good question.
yeah, that's a great question. I don't know if I can share my screen still, but I could just show you real
I
quick.
can actually make you presenter.
Oh, I
Okay.
could just explain if, okay.
We're stuck with you again. Yep, you should be able to share your screen.
Can you see my screen yet?
Yep.
Yeah.
Okay, so just real quick, this will be super quick. So this is one of the reasons why you want to scan a lot of gingiva. So let's say this patient didn't have any teeth, and we wanted to place a pin. So that pin's really high.
Actually,
We could,
Michael, your next question that was coming through was, what did you mean by a pin? So I guess you're killing two
oh,
birds with one stone. I don't know if that's a nice saying, but there you
okay,
go.
so we can place these pins here. So let me change the view so you can see a little bit better. Obviously, there's a tooth here, so we wouldn't be placing a pin in a real world situation in this patient's mouth. But let's say they didn't have any teeth, just for sake of argument. We can place security pins in the guide. So this has actually become part of the guide, just like the sleeve is part of the guide. And we can place these pins to secure the guide down to where we want it, so it's not shifting around during surgery. So somebody who has no teeth, or maybe they just have, we're extracting all the teeth and we're trying to leave a couple for the support of the guide, but we want a little bit more security. We can place these pins, and we know exactly how deep they're going. We know they're not puncturing through to the lingual. They're kind of settling into a harder cortical bone to secure the guide. So that really helps secure the guide on a patient with not a lot of teeth or totally edentulous. And it's just as easy as printing a guide. It just has extra holes to fit the pins in, if that makes sense.
So the pins are just for security and stabilization, basically, of a guide, if it could potentially rock.
Right. So if we work with a lot of full arch cases where somebody's wanting some, maybe 4 implants to place a denture on, but they're just, the guide's just sliding around on their gums. So we're able to place it, and they are able to place it, and maybe we put 2 or 3 pins in to secure the guide in place. And that's why it's so important, like I said before, make sure you're scanning a lot of gingiva on your intraoral scan so that we have space. Because if we don't have any gingiva scan, then we won't know where to place the pins, if that makes sense.
Makes a lot of sense. Okay, thank you. Okay, we've got a question for the GoEngineer team. What are the validated autoclave sterilization settings? That's a technical question for somebody who clearly maybe has worked with the printer a bit.
Yeah, so a pre-vacuum steam sterilizer should be set at 132 degrees Celsius for 4 minutes. Or you can use a gravity displacement autoclave at 121 degrees Celsius for 30 minutes. And the important thing, though, is you always want to include a 20 to 30 minute dry cycle to maintain the geometric accuracy of the surgical guide. Yeah.
Okay. Okay. Excellent. Okay. Next question. I have a Formlabs Form 3B printer. How much faster is the Form 4B when printing surgical guides?
Yeah, that's a good question. Well, it's approximately 4 times as fast.
Wow.
And as a benefit, another cool thing about the Form 4 with that resin is the vats for the Form 4B, like the container for the resin in the printer, which, that's a consumable over time. These cost a third less than they do on your previous printer.
Okay. So somebody might be upgrading soon. When you said the 4 times faster, it
Yeah.
sounds like it might be worth that
And
upgrade.
with
So,
some resins, it can go all the way up to 9 times as fast. It just
wow.
depends. But with that surgical guide resin, because it's translucent, it prints about 4 times.
Okay, you who asked this question, you make sure you scan that little barcode at the end of the webinar and you get in touch with these guys because 4 times is a lot faster. Okay, so
Important note on that too, Emily, if you don't mind, the resin is
Yeah.
actually cheaper on the 4. So not only are you producing the parts faster, you're producing them cheaper too. So win-win.
Excellent.
Right on.
So you're actually saving money on the upgrade ultimately. Nice, love it. Okay, we do have a few more questions. I've even had one text to me. I know sometimes like when people watch these and they're kind of busy and this and that, you guys text me, feel free. Send me an email, we'll get your questions answered. Can I disinfect the guide with liquid chemicals instead?
Yes, you can. So for that, you have to submerge the post-cure guide. So this is after you've done with the UV cure. You're gonna again soak it in this time 70% isopropyl alcohol, where we use 99% in the wash. For the sterilization step, at the end we'll use a 70% isopropyl alcohol for 5 minutes. It's important though to don't leave it in there for longer than 5 minutes because the alcohol will begin to degrade
Oh,
the printed part. And so 5 minutes is a cutoff.
okay, good to know. This question I'm guessing it's for the GoEngineer team. Maybe a little math required here, I guess, depending on cost and everything. But how many surgical guides per month do I need to do to justify buying a printer? Or what else can I print in clinic to justify buying my own printer? So how many basically per month would justify this? And knowing what you're paying when you go through a dental lab, I think the justification would come pretty quickly. But also, what are other items I can print in clinic? So to make it
Yeah,
worthwhile.
for sure. Well, honestly, in addition to models and surgical guides, you have a whole host of other applications that you can print. One of the most popular ones that people are doing are night guards. I have whole dental labs that I work with where that has really taken over a huge component of their business and has justified the expense of additional printers on top of what they already had because it's become so popular. And the resins and the materials have developed so much further in the past few years for that particular indication that it's become really a profit center for a lot of people. But also you're able to print temporaries, ceramics. We have the ability to print a premium teeth resin as well as a denture-based resin, so you can print dentures, removable partial dentures. So there's a whole bunch of indications on top of surgical guides that you can use these machines for.
Excellent. Okay, so it looks like I have 2 questions left. If you guys still have a question, send it on in and we'll make sure we get this answered. Michael, I'm going to start with you. Let me just make sure I'm reading this correctly. I think this will make more sense to you as a planner because you're working with the dentist all day long. I've placed implants using guides that have gone differently than in planning. How do I prevent this from happening?
Okay. Yeah, that makes sense. So often, I think I touched on this on the video. We always make sure that we do a full arch guide. Often planning can go not the way that you were hoping. Let's say you have just a partial guide that just covers, a quadrant of the teeth. That guide can shift around. So the more surface area that the guide is connecting with on the teeth, that'll prevent, the implant going one way or the other. Another thing to bear in mind is, let's say, for instance, a patient has really soft, spongy bone, but on the cortical bone is very dense. That dense bone, let's say we wanted to tap into that dense bone, that could start to lift the guide up on the others, on the patient's opposite side. So it's really important to secure the guide, maybe hold the guide with one hand while you drill with the other to make sure that the guide stays seated. Because in certain situations with really dense bone, you might have an instance where that guide is lifting as you're doing surgery. So you can prevent those things by making sure the guide is secure as you're drilling. I hope that makes sense.
Yeah, it does make sense. Very
Yeah.
helpful. Again, to me, it's almost a comparison of doing it freehand and guided. You're just eliminating all by planning ahead. You're not going to run into those issues, or you're not going to get results that you weren't hoping for. You know exactly what you're going to get if you're going through this process. And I love that idea. Okay, I think this is our last question. Unless anything else comes in, I'll be happy to ask it. Hopefully I'm asking this correctly. What layer thickness should I be printing my guides? And then it says with 50 or 100 microns. Like, so basically just I guess the question is to make sure that they're stable enough, that they're not fracturing, that they, can get them through the whole planning process.
Well, and also it really has to do with being able to capture detail. So that what they're talking about right there is the resolution of the printer in the Z height. And so uh, you'll notice that when I did that, I had like a preset that was already set up. And so it already sets up all of your layer heights and all of the parameters for the print based on the indication and the resin that you're using. But I just want to say that traditionally you always want to choose 100 microns for two reasons. One, it's faster. And then two, Formlabs did a bunch of testing on this, and they showed that there was negligible accuracy difference for this type of indication between the two settings of 50 and 100 microns. So we just want to stick with 100 for because it works and it's fast.
Simple.
And Richard,
like
you
it.
brought up a good point there too. Like this person is obviously printing already, so they know the difference. But it's important to note that you can switch the layer heights depending on what you're printing to achieve better accuracy, higher throughput, right?
Absolutely. And there's even some resins you can go even lower than 50. So if you want really accurate prints, this printer can create them.
Nice. Okay, well, that looks like we've got all the questions, unless something comes through as we're wrapping it up. And Drake, I know that you work on maybe a different side of GoEngineer. I'm not exactly sure what your official title is there, but I wanted to give you a few minutes. We're just super grateful to have you, and we do feel like that this is the future of how things will work. It just makes so much sense when you can cut back on so much time. You have control over accuracy, better care for the patients, and so forth. So just wanted to give you a second to talk to that and kind of maybe GoEngineer as a company and what you guys do, and then we'll wrap it up from there.
Yeah, awesome. Thank you. I think Richard put it beautifully. I mean, our goal is to reduce the amount of labor and cost associated with you doing what you already do well. And our role as GoEngineer is to provide the tools to be able to get you to that point, but also be a technical resource for you to learn, do things better. Beyond Formlabs, we have Stratasys printers, we have metal printers, so we understand the space really well. So regardless of what indication you're looking at printing, obviously we're focusing on surgical guides here, which can be a huge impact on your business. We're here to help. We're here to be a resource. My role is the dental accounts manager, so I'm kind of the sales arm of what Richard does for the technical side, and we work in tandem to make sure that we're providing solutions to help you run your business effectively.
Excellent. So if somebody was to reach out to GoEngineer and they could ask for you guys personally, kind of see a familiar
Absolutely.
face. I know going, you know, so again, I mentioned I was on the iOS side of the industry for a really long time. And I know when you take a jump into something more digital or bringing it in clinic and this and that, it can be quite intimidating. So it's nice to be able to reach out to somebody that you kind of know of and get some help and be able to reach out when there's issues or if there's questions. And you guys offer training to those who
Absolutely.
purchase? Okay.
Yep. Yeah, absolutely.
Yeah, a big part of what GoEngineer does across a vast spectrum of industries, from aerospace to medical to dental to automotive. You know, we have offices spread out across North America, down into South America, we have customers up in the Arctic Circle. I mean,
Wow.
we're a pretty serious engineering operation, and the way that we've been able to be successful is we're not just going to be selling you the technology, but we're also going to make sure that you are successful in the deployment of that technology. And so, and we made our bones doing that for over 30 years as a company. So with over 10,000 customers in our docket. So we're more than happy to bring those expertise to bear on your operation and make everybody as successful as we can.
Wonderful. Well, thank you guys very much. I just wanted to mention they should go check out your YouTube page, first of all. After we spoke the first time I went there, and I mean, you guys have just a load of followers. You've got a lot of videos. You've been around for quite a while, and you know what you're doing. So check it out. I think that it'll be worth your time. And then I wanted to mention we have some other webinars coming up. I was hoping to have the barcode to scan so you could get registered for those right away. We're going to go into a little bit more depth. We'll be working with GoEngineer on those as well over the next couple months, just to kind of provide more detail regarding the process. We know that sometimes it's hard to find information. Stay tuned for that. And then like Michael mentioned, I wanted to kind of bring up, he pulled up that CBCT file, one that was great, and then one with lots of scatter and issues and this and that. And so there's very specific things that the planners need in order to do accurate planning. Coming up soon, we'll have some information on and a webinar on how to take appropriate CBCTs to get the planners exactly what you need. You never have to call that patient to come back in and take another scan and so forth. We know that's the worst thing you can do. You never want to call a patient back and say, hey, guess what? You need to come back in here. So we'll keep you updated. I'm going to be sending out some e-blasts to all of our customers, and feel free to forward them on to any of your colleagues that you work with. And that being said, Michael, thanks for taking the time to do that planning session with us. We know that you do this all day long, so we appreciate you setting some time aside, and it was very helpful, very informative. So thanks for that.
Thank you. I
And
enjoyed it.
GoEngineer team, yeah, thank you so much. We know, you know, kind of as our guests here, we really wanted to feature you guys and give our customers somebody to contact. So we really appreciate the time. It was awesome. Thank you very much.
It was our pleasure.
Yeah, thanks for having us, Emily.
Perfect. Okay, well, we'll be seeing you guys soon. I'll get the information out regarding the dates and times and topics of our next session. And you guys have a great evening, and thanks again. We'll talk to you later.
Take care.
Bye-bye.